Catch up. And welcome back. We are starting to get to the pointy end in this course, and we're going to hear a bit from Ferg, who I'll introduce in a minute, and then later on, after Ferg and we have a stretch break, I'm going to take you through a few more things, but then give you your main assignment, which is to actually go out and do a safe system assessment or a safe system audit, and to put it into place. Now we've streamlined it and we've chopped out bits and pieces just so we get sort of the core elements of it to keep it to a minimal in terms of your time input. But it is sort of starting to go through the real process. But I'll take you through that in detail later. But I want to introduce Fergus Tate. Now, many of you probably know Ferg because he has been around road safety in New Zealand for quite a few years, and certainly somebody who's been instrumental in implementing a lot of the policies, practices, standards and guidelines that are used today. And Ferg was with consultancies before Waka Katahi, and now back in the consulting world with WSP, and did a few other things in between. And I think Ferg might even have a slide with a few of his dot points, which I think I put together originally, and then
I think you did, Ken. Yes,
right, and slipped it into his presentation. But we will hear a little bit about Ferg's background. And the reason I asked Ferg to be part of this course is because of his, just excellent technical knowledge in terms of road design, road safety, and the outcomes we expect, and how to create safe road environments. And secondly, just that intimate knowledge of New Zealand processes and practices, which is really important that we ensure that. So Ferg's going to talk about some of the how to approach those technical safe system audits and what to look for, and a few examples. It's a good opportunity to ask any specific questions you've got around these things, and I'll certainly be jumping in and talking to Ferg about a number of things. And I might kick that off straight off the bat, Ferg, and ask. You did your PhD in a road safety related field, and it wasn't in New Zealand, was it? It was over in the UK, if I remember. What was the topic?
I was actually studying a novel intersection warning system called Junction Action. It was titled the Junction Accident Warning System, or JAWS. It was a system that was supposed to supplement priority control, where if you tried to pull into the intersection and you didn't have enough time to clear the intersection before an approaching vehicle would collide with you, it would give you a warning. There were two types of warning. One was effectively like a flashing traffic signal head, where it would flash if you shouldn't enter the intersection. The other one was an in-vehicle audio system. Both of them were very, very good at reducing the time to improving the time to collision and things in a safety manner, but it never went anywhere, because the big problem was that the systems, instead of being a parallel warning system, so something you would go in, you'd do your normal looking left, right, everything, and if you tried to go and you didn't have enough time, it would warn you not to. What we found was that particularly for groups that struggle to actually judge gaps, they started to rely on the system and use it as an aid. Now, that has some quite serious consequences if you have system failure or something and it doesn't provide you with warning and you're using it as an aid. And one of the things that I had to do in the simulator study that we were using was I had cameras mounted looking at people's eyeballs, and I coded frame by frame the eyeball movements of the subjects and how it changed where they were looking and what was going on. It was bloody awful, to tell you the truth. It was 400 hours of sitting there frame by frame, and the only thing that helped me survive was Lou Reed, I tell you. But what it did do was it showed that, while this was a great system, people were not using it in the way that designers intended, and it could actually have very, very serious consequences as a result.
Yeah. Yeah, well, you could have used some AI technology back in those days to monitor those eyes for you. It would have saved you some time.
Yeah.
But it's an interesting one there. You're sort of talking about like having fail-safe mechanisms, and when you switch over to that other way, it is certainly like doesn't provide that. But yeah, that was a bit sort of groundbreaking thinking to a degree in road transport, and we still struggle with a bit of sort of thinking about failure and keeping it safe and not having that end reliance. But yeah, fascinating stuff.
Yeah, I think I was going to say, I was really, really lucky at my time at Leeds because I was actually the only engineer in the road safety unit. Everybody else was psychologists. And at that time, there's a few more engineers there now, but that combination of psychology and engineering became very, very powerful in terms of looking at systems and automation complacency and those types of behaviors, which was something I'd never have got exposed to otherwise. So I recommend to anybody, if you get the chance, go for it.
Yeah, well, I suppose safe system auditing and the origins of road safety auditing took some of that behavioural thinking further into account and mixed it with the engineering. So we do, as we've been talking about with this group throughout the last modules, we're trying to sort of predict road user behavior and failure, and then create environments that try to minimize the amount of failure and mistakes, but then cater for those that do slip through the gaps. So yeah, so you were really in the early days of that thinking from a road engineering and design perspective. Right, so you've got some content to go through for us, and I'll be jumping in with questions from the group and also some of my questions. Probably we may have some polls. I'm just checking to see. Oh, it does look like
Yeah, we've got a couple.
Okay, well, we'll be ready to launch those when you tell us, Ferg. But over to you.
Okay, I just sort of, this is a big topic. It's safe system auditing and the technical aspects of it is a huge topic. And I don't plan to cover everything. I think it would probably drive you nuts if I tried. So I'm going to focus on a number of things, particularly around the idea of what happens when you violate drivers' expectations and things like crash migration. Um, I want to have a look because typically on our rural roading networks in New Zealand, those are probably two of the biggest things. In New Zealand, about 30%, or for the state highways anyway, about 30% of DSIs occur on out of context curves. So this is why I want to look at these driver expectations and things, and also crash migration because they're so linked. Another thing that I want to look at is the design vehicles and checking vehicles and heavy vehicles in general, because again, that comes up regularly particularly in urban areas or in the arterial parts of urban areas. So that's something that comes up time and time again, which is why I want to include it. I want to talk about the different sight distances. And again, something that comes up time and time again. And so we're going to look at the common issues in a detailed design safe system audit. And then finally, I know you're not supposed to call them checklists, but I'm still old fashioned, but the prompt lists and the role of those when you're out on site. I think Ken has already covered most of this, so I'm going to skip that. I don't know just who I am and why I've got to talk to you.
But
Um,
that's in their notes that they can download with your contact details there, Ferg.
yep,
So if they
yep.
did want to follow up.
So they're there, and one of the great things I find after these sessions is I do get follow-ups from people. So don't be shy. I actually really quite like it. It means that you've got something interesting to ask and things, and it helps me develop content for next time and to work with you. But I have done a lot of work in safety reviews, safety audits, and crash reduction studies. I think one of the things which I want to talk to you about is the split that's happened with the new New Zealand Guide to Safe System Auditing. It's effectively taken two parts. It's taken the safe system assessment, which Ken talks about, which is vitally important, particularly in the early stages of the project, and the old road safety audit approach, and combine the two. And I think that that's really important, particularly in the early stages where the safe system assessment framework will help you in the feasibility and to an extent at the design. It's probably not much use once you get to the pre-opening, post-construction, which is where the safety audit, the traditional safety audit, takes a much bigger role. But one of the things that I always say is that as you are looking at the Austroads, in particular, implementing safety audits, it becomes increasingly less abstract. And I find that I thought we had a poll in there, but I can't see it. I find that what you find is that it's actually easier to start off at the pre-opening, post-construction, when you're actually looking at something concrete, and you can sit there and go, that needs fixing, that needs fixing. When you're working at the feasibility end, the data that you've got is far less, and it's far more subjective, and you find yourself asking more questions. What if? Or it's actually quite hard. And then in the middle, you've got the design stuff, and there's a certain art to actually being able to visualize those plans on the road. And I think if you're getting involved, if you can start off at the sort of right-hand side, if you like, with that post-construction and pre-opening, and work your way back to feasibility, it makes more sense. Unfortunately, we don't always have that luxury, but that's where we're going forward. I think these are some quotes from a 1997 Federal Highways publication, which I rely on enormously. I think I will read them because I think that they're worth it. Generally, drivers make fewer errors at geometric features that conform with their expectations than they do at features that violate their expectancies effectively. So, if things are going to plan, you make less mistakes, and particularly when you're driving down the road. If a road is consistent in design, so they don't have geometric features that don't conform, then the road should not violate the expectations of the motorist or inhibit their ability to control the vehicle. And consistent roadway design should ensure that most drivers would be able to operate safely at their desired speed along the alignment. Now, the number of times when you're looking at crash data and you see that a crash occurred because of inappropriate speed, the question is, what was the appropriate speed, and how did a driver know what was appropriate? What signals are we getting from the road environment about what's coming next that fits those expectations or modifies those expectations going forward? And as I said, 30% in New Zealand, 30% of state highway crashes, deaths and serious injuries occur on out of context curves. So I'm actually going to look now at curves and the factors that impact on the likelihood of making these mistakes. And there are two things that I want to talk about in particular. One is curves that are difficult to read, and the other is curves that are out of context. So while you might see that they are tight, that they're violating your expectations coming through. The other is that it's hard to actually set expectations because they're difficult to read. Now, when we're thinking about curves, the curve negotiation formula is E, or the super elevation, the cross fall, plus F, which is friction, the resisting forces, if you like, equal the forces that want to make the vehicle lose control, which is velocity squared, V squared, over 127R, which is the radius of the curve. So on one side, you've got the resisting forces, E plus F, and on the other side, you've got the forces driving loss of control. Now, I think
I think I got a poll for that one.
I think we've got a poll here, haven't we?
I'm going to
So
launch that. Hopefully that's appeared on people's screens. Which has the most influence is Ferg's question. EFVR, and he's just explained them there. So there'll be a bit of getting a few answers coming in. Oh, well, people have their guesses on that, Ferg, or have their predictions on it. Sort of jump back a little bit. You were talking about sort of the stages of safe system auditing and when it's easier or harder to see what's going to be built and understand it and find issues. With the inclusion of the safe system assessment process in this road safety audit process, there's been some discussion around about the weirdness, I suppose, of doing the safe system assessment matrix in a sort of post-opening scenario. Like, so it's been built and you're doing some sort of audit check. Do you have any commentary around that? I mean, I don't think many people have done that yet because it's so new, but is that just a validation of what might have come out of it? Or do you think it's sort of just, yeah, any thoughts on that?
I'll give you my thoughts.
Yeah.
I personally believe that there is little value in doing a safe system assessment on the post-construction. I think it has its greatest value down at the preliminary stage where you're looking about making choices. But most of the stuff that you pick up sort of post-construction, I mean, if you're thinking about it and you do a safe system assessment at post-construction and it says that the best solution is a roundabout, well, it's too freaking late. You've built traffic signals.
Yeah.
You know, and I don't see much point. And it's not a good tool for saying this crosswalk at these signals should be staggered or not staggered. The safe system assessment doesn't have that level of detail. So I actually think it's probably you're better in that right-hand end post-construction. I don't like the idea of the safety audit becoming a snags list, but that's sort of more the place that you're operating. Where the safe system assessment has got the greatest value is when you're trying to work out what is the best form from a safety point of view for doing the something, and you're comparing options. Once your option is decided and things, you can use it a little bit to look at detail within the option. But again, as I said, it's not very good at very detailed stuff because it's a hell of a coarse thing. And I mean, one of the things that I find, you know, if the volume is more than 10,000, it's a 4 on exposure. Well, if you have a bypass road that you're looking at and you've got an existing road that's carrying 24,000 vehicles a day, and you take half the traffic off it and put it on the other road, you now have 2 roads which are scoring 4, whereas before you had 1. So it's not got the level of detail that you might want in that space. And things. So as I say, and when you get to the very end and you're looking at things like that sump grate should be a cycle-friendly one in this location or any location really, and it's not. It's really hard to score in a safe system assessment. It's a nonsense really to think about one sump in an interchange or something like that. This is where the safety audit part it comes into its own.
Yeah, I think that's beautifully described because it is such a broad brush treatment, and where people trip up is seeing that it has scores and thinking it is some sort of precision tool, and not seeing it for just what it is, which is to give a broad brush indication if that treatment or that intersection control or that cross section is as well aligned with safe system as we can. Any experience with that misuse of the scoring, Ferg?
Oh, so many times at the moment. The value of the safe system assessment is not in the scoring. It's in the questions that you're answering and the commentary that you're writing around what you've done. So when you're actually writing it up, you'd say, this project is for some, 50% compliant with the safe system, whatever that means, but it would score higher, or it would benefit from having a full medium barrier throughout its whole length, which would make it safe system compliant. Or it would be more compliant if we went to a wide centerline treatment, because we can't fit in the barrier that we'd like to put in. It's all about, this is where it is, but it would be better or more safe system compliant if you did this, this, and this. Or the flip side of that is, this is scored poorly because it allows head-on crashes to occur. And if you wanted to get more safe system compliant, then you would put in the barrier. It's all about the commentary, not about the score. And in fact, if you're not careful, you can end up in a situation where, say you've put in a bypass and you're now comparing an existing road with an existing road and a bypass. If you don't treat that all as one whole project, you could end up doing two safe system assessments to look at the likelihood of crashes on the old road and the likelihood on the new road. Suddenly your denominator has got much larger and your score is much larger. So you need to be talking about the score as its proportion of the denominator, or how close to a safe system it's becoming, rather than this is 327 and that one is 156, which really at the end of the day is meaningless. And one of the things that, Ken, you'll be aware of this, we've had a number of people come to us recently and say, okay, that's fine, you've got 327 and 156, tell me what will be the impact on DSIs of these scores? And that's a really, really difficult question, and probably more than anything shows that they don't understand how the safe system assessments actually work. And what I've said to the guy who most recently asked me that question is, you need to go away and read that safe system Ostroad's guide, and then come back and see if you still want to ask that same question, because you'll have an understanding. I think we've got problems in that space with people who don't really understand what's involved. And I mean, you're asked to rank things on a scale of 0 to 4.
Yeah.
And as I've said before, that there are some criteria for a 4, but sometimes they don't make sense.
Yeah, yeah, and that's right. I think that certainly, like to try to link it to DSI is a complete that doesn't make sense. That would be a different study in its own right to try to predict DSI savings. And certainly that granular nature of the assessment methodology, it actually, in my opinion, has some advantages if used correctly, because
without a doubt. Yeah.
It doesn't, it shows you that, a warning sign, won't substantially address a risk, but because it's not actually going to change any numbers. But as you say, if it's used incorrectly, it can be very very dangerous. But let me put the results of this poll up there, Ferg, because we saw most people saying V, the velocity there, is going to be the most influential in that situation. So
yeah, and then the next question that comes out of this is, what governs V? That decision, what is the appropriate V? Now, if I look at the equation, friction. Who can see friction? As a driver going down the road, making decisions about what sort of V that I want to go around the curve at, I can look at that road. Can I see friction? No, so it probably doesn't come into the equation. Can I see super elevation? E. Well, you can probably feel it when you're in the middle of the curve and you can feel your vehicle canting over. But coming up to it, it's actually very, very, very hard to see super elevation. So it's not in there. So it's not telling you anything. The only thing that's really telling you about what V to use is radius. And there's quite a lot of research that looks at the impact, and that shows that drivers use radius in order to determine what V they should have. So if I go to now to curves that are difficult to read, this is some data that was collected by Shane Turner and myself, people driving 488 curves, I think it was, which looks at the radius of the curve, so the R, and the design speed of the curve. So if I'm looking at the radius and it's 300 meters, it could have a design speed of 60 kilometers an hour, or it could have a design speed of 100 kilometers an hour, depending on those other factors. So while R is something I can see, it's not telling me a great deal about the design speed of that curve. And there's a lot of scope in there to make mistakes. But I'm looking in here. This is some data that looked at the mean curve speed of a sample of drivers. And what you're finding is sort of from here at about 450, above 450, that's sort of behavior on a straight. Even as we come through towards 300, there's a slight downward trend in that data, but it's not actually dropping. Negotiation speeds are not actually dropping until somewhere below about 250 meters of radius. So what you're finding is that, one, people have a wide range based on their prior curve negotiation. They make a decision about what this radius is going to give them, and it could vary by 60 to 100 kilometers an hour for the design speed of the curve, and they're not changing their behavior really as they come into those curves for somewhere between 250 and 300 meters radius and about 450 to 500 meters radius. So these curves in this band are the curves that are hardest to read and to make the appropriate decision about what V should be as you go through the curves. So yeah, and I mean, looking at that data again, we were talking about the 300, people were negotiating those curves, which could be as low as 60 at sort of speeds that are sort of in the 90s, up to 110 for the 100 curve. So this is the 85th percentile speed through the curves. So what it's really telling us is there's not much change in behavior for these curves, and they can have very, very, very different design speeds. And as a result, these are the curves that are hardest to read. And in fact, New South Wales, when they were first looking at this, it was work by Steve Levitt, which is extremely good work, actually prioritizes for treatment curves in that sort of 250 to 500, 200 to 450 band in there. I think they actually go 300 to 600 as the curves that you need to be looking at first, because they have the higher crash rates because they're so difficult to read. The other thing that becomes really important is the length of the curve and the crash rate per curve. Obviously, you've got more exposure on longer curves, but you'll see that the way that this rises, and so on longer curves, it's harder to straight line them and to effectively flatten the radius. And the other big problem that you've got is as you go into them, if you make a miscalculation, you've got less scope to recover and get out the other side without crashing. So the sort of first thing to look for when you're looking at these things is curves that are in that range of, say, 250 to 500, and particularly the long ones, because those are the ones that go back to that Federal Highways document. They are violating expectations, well, they're actually not setting up the appropriate expectations, and as a result, are difficult to read and have a high crash rate. The other thing is hiding them. And you know, the things that you should watch out for are things like I've got one here is dips where you've got something hidden in the dip, like a railway crossing or a curve. You have two curves of the same sort of radius in the same direction, but different design speeds. These broken back curves, you really want to try and separate them by 2 seconds of travel time. So sometimes when you're looking at alignments that have got curve, short, straight, curve, you're much better. And I know the computer program will tell you that you've just violated your cuts to fills, but if you think about the bulking factors that you've got for fill, it's a nonsense anyway. It's something that came out of a computer. You're actually better off putting in a single larger radius curve and adjusting the earthworks than you are of putting in curves that are quite close together. I recently, Keith Wheel from, she wasn't that recent, it was a few years ago now, but Keith Wheel showed me a vertical alignment, which he was auditing. In 800 meters, it had 6 different vertical elements. That's just computer nonsense. You know, at the end of the day, you can do that alignment with a single curve and get a much better, much easier to read alignment out of it. So, you know, what you really want is to make sure that in plan and in profile, your curves are coordinated to give you a smooth flowing alignment where people can see what's ahead. Because one of the problems that we'll talk about it under sight distance is we spend an awful lot of time looking at sight distance to an object that's 200 millimeters high, or 150 depending on what it is, or 800. They're great, but how do you actually know where the road's going? That means you have to rely on the marker posts. You're better off with an alignment that's flowing where people can see the ground and see where it's flowing. That gives them more information to make better decisions about what's appropriate in terms of speed. The other one I want to talk about is out of context curves. And what do I mean by out of context curves? Well, I don't know how many people are from Wellington, but all around New Zealand, we've got the Kaimais, we've got the Rimatakas, we've got the Pahiatua track, we've got the different passes across. On those passes, we have small radius curves, 120, 80, 150. When you're on those roads, those curves are in context. However, when we're on the plains around the Awatri Valley and things in Blenheim, and the road goes down the straights of the railway line and then does a really tight curve to cross to the other side of the railway line, that curve is out of context. It's not expected given the approach context, and these catch people by surprise. And there's a strong relationship between the curve speed and the crash rate, the difference between the curve speed and the approach speed and the crash rate. So if we're looking at a 10 kilometer an hour difference between approach speed and curve speed, there's almost no difference in crash rate up to about 10 kilometers an hour. It goes up by about 25% if we go up to 20, and it more than doubles if I go up to 30. So the degree to which a curve is out of context has a major impact on the crash rate. So if you've got a tight curve and a generally tighter alignment, you're down here around the 10. And if you've got a tight curve at the end of a long straight, you're up here at the 30. And it has a major impact because what you've had is the previous alignment is setting the driver expectation about what's coming. And when they come into one of these tight curves, there's a real oh shit moment going on. And if you're not on your game, that's when the crashes occur. So the degree to which a curve is out of context, and it's important to understand that, you know, people say if we designed our roads better. In New Zealand, we redesign about 1% of our network a year. So it's going to take 100 years, if that, to get our whole network designed. Most of our network evolved, it wasn't designed, and it has these problems in it. So one of the things that happens is that you fix this curve and you improve a curve and you take it from this curve, it's usually the first curve in a sequence of tighter curves, and it's got a 30 kilometer an hour difference, and we improve that and take it to a 10, which means that the next curve now has the 30 kilometer an hour difference, or maybe only a 20, but it's still high. And what you end up with is the crashes migrating to the next curve. Now, one of the most frustrating things that you can find is when the client says, you cannot talk about that next curve because it's out of scope. our project finishes here at this intersection, and you're talking about this curve down here. It's out of scope. First answer is that's bullshit. Your job is to look at factors that will make it safe for the road users. And if that means that the crashes are migrated to a curve downstream, you need to be talking about this. And this happens all the time, because what tends to happen is our projects finish when the going gets tough or the dollars get big. And the classic would be things like realignments and passing lanes, where you do it until such time as you hit some enormous bluff that's going to be too expensive to modify, and you stop. Which means that in the case of passing lanes, you increase the speeds, because passing lanes increase speeds, up to a point where there is a geometric deficiency. So you're now actually increasing the degree of out of contextness, because you've wound up speeds through the passing lane section, and it's drifting on, and then you had an out of context curve, which is now even more out of context because the approach speeds have got higher. And it's a bit of a travesty. We did some work for Austroads a few years ago and found that almost half of New Zealand passing lanes resulted in an increase in crashes when we looked up to 5 kilometres downstream before and after. And that's simply because what we've done is increase speeds into geometrically deficient features. And that's something to be really careful of, and not to be bound by the scope of the project as you go through.
So Ferg, on that, and we have another question in there from Jesse, which I'll get to in a bit. But just questioning on that, like, okay, if you're doing an audit, a safe system audit in Upper Hutt, and you're driving up there, State Highway 2, and you see something along the way that's a road safety issue, like, is that part of your audit? Like, where are you drawing the line? How do you think about that?
Okay. If I was going up, I would probably, and it was sort of on my way to the job, which, is also downstream of the job when you're traveling in the other direction. And I'm looking at it. There are other mechanisms to say, contact the client, put it in a covering letter, in an email. I was concerned at what I saw. In terms of drawing the boundary, I generally look at the crash migration. It's usually it's not a hard and fast rule, but it's usually the curves immediately downstream. So probably in the next 2 or 3 kilometers to see what they are. I mean, what you'll find is it's usually the next geometric feature that's going to have the migration occur to it.
Yeah.
And because that feature then controls the migration to the next one. So you're looking at that in ones immediately downstream, the ones that are likely to pick up the migration from what you're doing. And in your commentary, you can say, we are expecting crashes to improve on this curve. However, if you're going to do something and get this back in, there used to be in the old design guides this idea that you could step down at 10 kilometers per hour. And if you go back to that out of contextness, that's telling you if I did multiple steps of 10 kilometers an hour, I shouldn't experience, I start to change people's expectations about what's appropriate, and I shouldn't be experiencing large out of contextness. There was one that I saw that, you could do up to 20 in a single step, but if you wanted to go beyond that, you needed to do tens. I think working in tens is probably the better way. And then you can look at how far until you come back online, if you like.
Yeah. I suppose you kind of answer it with your use of the term migration, really, because as you say there, the project has to kind of influence that next curve and the way it will be used. And that kind of draws your line, really, doesn't it? Because the one
it does.
10 kilometers away, well, the project's not really influencing it in any tangible way. So yeah, that first curve or the first next few are really going to be influenced by how that project comes into it. Yeah, good. Thank you. Now, Jesse's question it's probably more one we've got to ask Tawaka Katahi directly, and it goes back to our earlier discussion around post-construction and whether you could omit the safe system audit part of it. My understanding at the moment is they're saying, no, we want that consistently done for all to ensure. I think as they do their review of the safe system audit process, which they're saying they're putting it out now, everybody's using it, they're going to take feedback. I think that'll be part of the feedback. But for now, I'm told that for every safe system audit, you go through the full process. So yeah, I don't think that is the case. But I will double check in with Waka Kotahi, see if they've changed their opinion on that for now. Okay, back to you, Ferg.
Okay. So when we're actually doing the safe system audits, I think it's important to actually make sure that you're properly informed when you're going out, and thinking about who's going to be the users, in what sort of volumes they're going to be using it, and particularly now with the safe system assessment framework, that traffic data and the types of vehicles become really important. The volumes of cyclists. It doesn't have to be perfect, but because if you think of the safe system assessment framework, those bands are quite large. One of the things that I like to have a look at, but it shouldn't drive the road safety audit or that part of the safe system audit, is the crash history. What is the problem that you're trying to address by what you're doing, if there is a safety issue there, and how are you actually going about addressing it, which I think is really important in any previous audits that have been done and what they were doing. One of the questions that often comes up, Ken, and I don't know what your thoughts are on this, but in the very first preliminary audit, for some reason they've chosen traffic signals, and the auditors have said a better safe system solution for this site would be a roundabout. But they go ahead and do a design, and then you audit that. Do you again say the best safe system solution for this should be a roundabout? And then what happens when you've constructed it, going back to what we've just been talking about the safe system? The best solution would have been a roundabout. It's too freaking late by that stage. You really have to think about what it is that you've got now. What are your thoughts about that?
Yeah, so it's kind of as you've done it. We're certainly very strong on that in the early stages. As it progresses to a detailed design, that to me, those sorts of fundamental design choices or project choices, I start to put into the commentary section in the lead-in introduction rather than a distinct finding. And then at the later stage, once it's constructed, again, it might get a little note at the front, earlier audits or earlier discussion suggested, are these other treatments for reasons outside of safety, it was chosen to do that other one. And we've now identified, particular detailed issues with the signals, because you're right. I mean, they're not going to rip it out and put a roundabout in. We focus on that. Yeah, good.
Although it's interesting, we had one that Colin Brodie used to use quite a lot, which it took time, but in the end, yes, there was one called Miani Key in Napier, where I think the preliminary design audit said this should be a roundabout. The detailed design audit said previous auditors noted this should be a roundabout, and we have serious concerns with the priority intersection. It did take probably 7 years and a number of DSIs before they finally ripped the bloody thing out. And guess what they put in? A roundabout. So it felt, well, I was going to say it felt good to be vindicated, but obviously there has been loss of life and injury in the interim period, which is, what we're trying to avoid.
Well, the integration of the safe system assessment matrix at the start will be another way that just reinforces that's probably not the appropriate treatment, because it'll have to be there, and it'll show increased scores in a number of areas.
Yep.
So it will be a consistent highlight, which is one of the reasons why Waka Kotahi's crammed it into the front of every audit, because if you have gone down a path that we don't feel has the best safe system outcomes, it will be front and center when people read that report.
Yep. Okay. So heavy vehicles, as I said at the start, heavy vehicles and heavy vehicle tracking is one of the things that comes up regularly in the audits that I've been involved in, particularly in urban areas, and there seems to be a lot of confusion around what's actually going on. So I actually had a question in there. Two of the key things, who can tell me the difference? Because when you're looking at heavy vehicles, we have a design vehicle and a check vehicle. And I think we had a poll at this point, Ken, but I don't seem to see it.
No, I think we might just have people write it into the chat for us, and the first
Okay,
person to write in there in the chat can have a prize even. So you're asking what's
okay,
the difference between a design vehicle and a check vehicle, or what?
exactly.
All right, we'll see what people come back with as their guesses. Remember, you're not marked on anything we put that happens in the live session. You've got a little quiz afterwards to check that, but. So we've got Jesse said design vehicle is the everyday use of the intersectional road. Check is for more low use cases. And then Matthew's just jumped on the bandwagon there of Jesse's comment, said, yep, agree with that. That sounds pretty good. What do you think, Ferg? Anything you'd like to add to that or tweak?
I think that this is wherever practical, the design vehicles tracking should not encroach outside into the adjacent lanes or shoulders. So it is the everyday use, but importantly, it should fit within the design. Whereas check vehicles, you're talking about the occasional larger vehicles, can they actually get through without they can encroach on the other lane, because typically they will have pilot vehicles and things, but they can actually make their way through the intersection of what's going on. And I think one of the things with them as we're going through is particularly things like mirrors and overhangs. And I'll go through some examples. Some of these are Ken's, which I've stolen. And I've got them in here, but we'll go through. I think the big things that we get with the vehicle is the choice of the wrong vehicle. You know, everything does not need to have a quad axle semi go through it. There are lots of situations where that would be an over design, and that quad axle semi might actually be the check vehicle, not the design vehicle. But choosing the right design vehicle, one of the interesting ones that you typically find, the quad axles and things like that are articulated vehicles. And while they're very big and have quite complicated turning, often in urban areas, a tour coach, particularly if it's only front steer, will actually be a more difficult case than a quad axle, because the quad axle is articulated and the fixed vehicle isn't, and it has a much bigger swept path, particularly because it's got bigger front overhangs. So while people are saying, oh, I can get a quad axle semi through here, you may not get a tour coach through there. So choosing the right vehicle. And you think schools, well, around a school, often there are school trips, they use tour coaches. So in an urban area, making sure that the roundabouts near the school can actually accommodate those, whereas they might accommodate on their aprons a quad or some articulated vehicle. They won't necessarily take a bus. The big ones, the other big one that comes up time and time again, I get people send me the swept path for the vehicles that they've tested on the site, but they never include the speed at which that turning's been done. And I had one recently where the idea was that there would be a jug handle turnaround, and the heavy vehicle would make a right turn, sweep through the turnaround, and pull back out onto the highway. When I sat down and looked at it, it was going to have to cross, well, apart from the fact it was, in theory, a filter turn across two lanes by a heavy vehicle. When I looked at the swept path assumptions, the turning paths were for 10 kilometers per hour. Well, that isn't going to happen. You know, it would be really dangerous to try and do that type of swept path movement at low speed, because you're increasing the exposure. So you need to know what assumption was made when you're looking at the turning, and it becomes really important where you're going lock to lock. Because if you're going lock to lock in a heavy vehicle and you've got a design speed of 5 kilometers an hour, there's almost no drift. But the minute you put that up to 10 or 15 kilometers an hour, that doesn't happen like that, because you're moving forward while you're desperately trying to swing from lock to lock, and things. The other thing that often you find is that the swept path doesn't take account of the driver view angles. Some years ago, I was looking at an intersection called Kennedy Road, and what they were finding was that the heavy vehicles to the port came off the off-ramp, and they were supposed to swing around a right turn into their own lane. But they were all encroaching on the left lane as they did it. And that was because in order to see what was coming, they had to come up slightly off square to the left, so they could look back over through their cab and over their shoulder to see the traffic that was coming up on them. And as a result, they were wrongly positioned for the swept path. So you have to take account of what the driver's view angles are so that they can be properly positioned to start the curve. And finally, the other thing that really can cause problems is the takeoff point. And this is particularly an issue at roundabouts. And I've got an example later on. You have to make a decision as you enter the roundabout, so that you can clear the exit of the roundabout, which is something you cannot see. So you may need to be positioned extremely to the right on entry in order to actually get out the other side. So the takeoff point that governs negotiation further around the roundabout becomes important. Yeah, and as I say, the common issues are encroachment in other lanes, encroachment into pedestrian areas, particularly with buses and coaches and large rigid vehicles that cut the corner, and you'll see crash down curbs. And the other one, my friend Frank Lai did a big study of pedestrian bus issues in the UK at one stage. The biggest issue they had was pedestrians being struck by the wing mirrors of buses as they waited to cross the road. And you can imagine a big wing mirror to the head is going to hurt like hell. If you're lucky, it could actually cause real damage. And then vehicle conflicts within the intersections and with roadside furniture. So I'm looking at a job here, which has been set for a quad axle. Its lock-to-lock turning time is 6 seconds, which is reasonable. It's hard work, but you can do it, and it's also been checked. But if you have a look here, this is quite a heavy freight route, and they've made use of the fact that Ostroad says you don't have to have two heavies doing the same maneuver. You can have a single unit and a heavy doing this. But as you come around here, there's issues in here. You can see my mouse, can't you, Ken?
Yeah, yes, it's small, but we can see it.
Okay.
And so, I have some questions for you when you're done with this, Ferg.
Oh, well, do you want to fire for now, or?
Oh, okay. Well, one was around, I mean, sort of what you're talking about here, but are there any rules around road speed limit versus acceptable check vehicle maneuver speed? So that relationship?
Not that I'm aware of. I haven't, and it is typical that we end up with low speed. Most people use low speed, particularly from lock to lock. So no, it's something that there are no rules that I'm aware of.
Yeah.
But it is something that you need to check. Yeah. What's your next one?
The next one was, is there any calculation that will take drift into consideration, lock to lock and moving speed, or times moving speed? I'm not sure I quite understand that.
Okay, I do. Yeah.
You do, yeah.
Yeah. What you're saying is, if you're traveling at very, very low speed and you go lock to lock, and you're traveling and your lock to lock time is 6 seconds, which is quite a lot of turning. If you're doing that at low speed, you can accommodate, you have far less drift as you go through your tracking path than if you're doing it at high speed. So where you've got reverse curves, and I think I've got one in the Namanutawa intersection that I've got later on, you'll find that the tracking path suddenly changes from lock to lock almost instantaneously at a point, and that's almost always because they've used a low speed tracking curve rather than a high speed. Looking at this intersection here, the big one is this left turn out, which you'll see is on a giveaway. It's helped by the fact that the main line has a signal on it, but you cannot make that maneuver without encroaching in the opposite lane. The other thing that's really interesting about this one is if you have a look at the road markings, you're quite a long way round when you're trying to make this curve out here, and you're looking back over your shoulder to see what's going to hit you. This should actually be a lot squarer coming in, in terms of what's going on with the red road markings that are there, and you cannot actually get round in your lane. These ones here, there should be more separation as we're coming around parallel through here, and again as we come down here. The recommendation is that you should have a meter between two vehicles that are coming around together, and this gets quite, what's happened there? This gets quite tight. And again through here, you're very, very close to the curbs and to people who are waiting to cross for the left turn, and again for the right turns when they're there. So this is very, very tight. And interestingly enough, it's not actually telling you what speed the tracking has been done at. But you would expect this to be at reasonable speed, because although these guys could be stopped on one phase and pulling away at low speed, if they're coming towards the end of the traffic signal phase, they could be running at a reasonable speed coming around here, and therefore they need a lot more room to play with.
Yeah, and there was just someone seeking clarification on the term lock to lock and exactly what that means.
Okay, so if you're hard over on hard lock to the right, and then you have to do a reverse turn and turn your steering wheel to go all the way over to the left lock. So your hard lock on a left-hand curve. So you're moving from left to right. If you've got speed on, you get quite a long forward. You're traveling quite a long way as you go from max turn to maximum turn in the opposite direction.
Yep. Right.
Okay. Okay, so common ones. If you see, I mean, I historically have driven buses, so I have some and the odd truck, but not quad axles. But if I see a turning curve that looks like this, you know that this is bullshit. And this is somebody who's invented a turning curve to just make it fit. You would not, if you were driving, do this where you're turning this right turn from the side road on the right, where you turn, you slightly reverse turn so you don't get through there. You come forward, you turn and just avoid the curb on the other side. That's a nonsense. That's a made-up turning curve, because if I'm coming through here in my bus, I make that in a single maneuver and I encroach on everything as I do it. There's no way Mr. Joe with his hat on backwards and his sunglasses on is going to actually know that the only way to get through this intersection within the confines is to do a little bit of a turn and then turn back and then do another turn. It doesn't work like that. That's an artificial situation to just get you through. And things. So I would be sort of alarmed when I had a look at this. Here's another one that's coming up. Now, this is one of Ken's. Is this your bus station one, Ken?
Yeah. This is a brand new bus interchange.
Okay, so I mean, apart from the fact that there's a whole bunch of blue lines that are almost going right over the curb to actually get through here with the overhang space, what would happen if you were waiting? Even better, those are visually impaired tactiles. If you were waiting there and the bus was coming around here, this long rigid bus, and this goes back to the fact that long rigid buses, particularly if they're only front steer, are absolute dogs of things in terms of their swept path, because they have quite a big overhang front and rear. And make it very difficult. So this is, what do you have at bus stations? You have pedestrians waiting to catch buses, and this doesn't take them into account in any way, shape, or form, particularly for that left turn with the overhang there. And he can't even stay in his own lane over here, and it would be quite possible at this situation to have a vehicle waiting to turn in or turning in as one is coming out, because those are the vehicles that are using it. So all in all, it's not a particularly satisfactory set of design, is it, Ken?
No, and yes, for a brand new bit of infrastructure like that, fairly disappointing.
Yeah. And this idea that 12.5 is the radius that you should be using, when you've got long rigid vehicles, that goes out the window. I mean, he's having to start to turn from way back, and the overhang is quite high. Yeah, so I did have a highlighter. Here's the other direction, at the same bus station, same type of thing happening. This one actually ends up, I think it doesn't quite encroach, but the one turning out does. And it would be quite possible to have both of these vehicles at a busy bus station operating at exactly the same time. They're not even protected by signals. I mean, you could possibly make sure that this one didn't move at the same time as this one. It would be very inefficient in terms of signaling, and you can't stay within your lane as you're going through. Yep, so there. This is Namutawa roundabout. Now, here is one of these lock-to-lock points here. So you're coming in here and you're turning very hard on a left-hand turn to get around the first part, and then you've got to go hard over to the right-hand turn to get around. Now, as the speeds increase, that isn't a point, it becomes a flat, and this actually moves out. So lock-to-lock is, I always look for these. This is another one where you're coming through, you're going to make multiple steering adjustments, even for a car going through there, let alone a heavy vehicle. It will tend to track straight through and probably encroach on anything. This is actually the heavy vehicle bypass for the town, and this is the industrial area over here. And so it would be, although Ostroad says that you don't have to have two heavy vehicles together, in this situation, that would be quite possible. The other thing that's really interesting on this one is this vehicle here has to be as hard over as it possibly can here in order to get out the other side of this intersection as it comes round, because otherwise it gets stuck. And here's another lock-to-lock with a bit of drift on it. You'll see that it's got slightly higher speed. It's flatter through there, as opposed to this point where it's low speed. It's assumed to have gone hard from lock to lock. This is another one where the swept path doesn't account for the driver's view. If I'm sitting here in my truck, and I'm around enough that I don't hit the barrier as I make my left turn out, I can't actually see back behind me to see the vehicle that's going to hit me when I pull out. So the swept path doesn't account for the driver's view angle. If I square this up so that I can see better, which is what the truck driver is probably going to do, he's not actually going to get round inside that barrier. So there's a very high chance that that barrier terminal end will get damaged quite regularly, which means that you've got a safety and design problem because people are going to go out. Not only that, it's because it's the terminal end, it's the most expensive part of the flaming barrier. So it's not particularly useful in that space either. Right, when you're out on site, you can see where there are problems and things. You know, this guy here cannot get around here. The evidence is quite clear that they've all been running over the curb. Same here. Again, in order to get round here, they're having to swing wide into here, or their trailers are coming wide so that you can go up there. Damage to infrastructure again as a result. So these are all things that you can see when you're out on site that give you an indication of that there's something that's just not right. Sight lines. Oh man, there are so many different sight lines, aren't there? To other vehicles, to other road users, to the pavement, and that they can be restricted by the alignment, by parked vehicles, by stand-up angles at the intersection, as I've just said, those approach angles that can muck up your sight lines. One of the most important ones is we always talk about safe stopping sight distance, and it's typically to an object that's on the road, so that, you know, if you see an object. Somebody once told me that the object was supposed to be 200 millimeters high because that represented a body lying on the road. You guys can't see me, but I can tell you that my body is a damn sight bigger than 200 millimeters lying on the road, that's for sure. But if you can't see the pavement, you have to rely on other features such as edge marker posts or other hedges or fences to tell you where the road's going. So as much as possible, we actually want sight lines to the pavement. And this is particularly important at intersections because it tells you where to stop and where you're tracking. But even on rural roads, particularly if you've got side roads and things like that, you can't have edge marker posts. You're relying on RRPMs and the pavement markings to tell you where the road's going. And if you can't actually see to that road surface particularly well, it makes it very hard to negotiate, makes it very hard to see the curves and work out what the appropriate speed is, but it also makes it very hard to work out where you're going as you go through. So, I mean, the standard ones are the safe intersection sight distance, where things like parked vehicles, fences, hedges and things can create problems with the sight lines. And again, you know, if you're looking at this bottom picture here, if you're looking to the road surface compared to another vehicle, you know, you're only seeing half the distance if you're going to the road surface in that diagram. So it's really important to make sure that where you need to see where people are coming from and things. And the classic is where you've got left turning vehicles with slip lanes. And you can't be sure whether the vehicles in the slip lane are going straight through. And you make the wrong decision about thinking it was in the slip lane and it's not. And things because you can't see the vehicle in relationship to the markings, because you can't see the markings because you can't see down to ground level, which becomes really important. This is a one of Ken's. You can tell because the houses aren't that flash in New Zealand. And things, but looking at this intersection here and how the sight distance is restricted. In this case by parked vehicles. Now, if you're looking at that and there's a Toyota in the front of the picture and then there looks to be some sort of Land Range Rover or something, you can just see the roof of the Mercedes, the top of that Mercedes as it comes through that white bit there, just coming through. You know, there isn't the sight distance is insufficient to allow you to actually identify a gap that you can pull into, and therefore, you know, you've got a high probability of making a mistake. And things. So, in terms of the sight distances, the OST roads, you know, we've got stopping sight distance, approach sight distance, entering sight distance, maneuvering sight distance, minimum gap sight distance, overtaking sight distance. I think the big thing is that you need to actually work your way through them for the situation that you're working at. And then while things like stopping sight distances, I've said, go to object heights, you know, is it appropriate at that position? Should we be looking at the maneuvering sight distance and looking at what's on the road? The overtaking sight distance, I think, is 450 meters, typically for a driver to safely commence a maneuver. In some situations where the differential between the overtaken and the overtaking vehicle is very low, you may find that that's actually overkill. Whereas, and for the approaching speed of the opposing vehicle, in other cases, it will be marginal. So you need to have a think about the specific situation and what's giving you the clues that you need in terms of that sight distance. So common issues that I found, particularly around, is things like see-through effect. That's where you're coming up and you're at one intersection, but the road is actually projecting away from you, and you don't notice the intersection because everything is leading you down the road. Stand-up angles I've already talked about, which is the angle at which the vehicle is located for the sight distance. I think the other one that comes up time and time again is safe stopping sight distance at an intersection should be to the back of the queue if queues are going to be there regularly. Everybody checks the sight distance to the intersection, but if you've got a 50-meter queue night after night after night, or a 100-meter queue night after night after night, you need to be checking the sight distance, the safe stopping sight distance, to the place where you think you're going to have to be stopping, not the place at the front of the queue. Line marking issues. Line marking, and particularly when you're thinking about line marking, thinking about motorcycles and mopeds. There's nothing worse than wet line markings in the braking zone. For those guys, I was only the other day, actually, I was walking up to the office and I watched a guy. He was a learner on a scooter, but he hit the big wet arrow, and yep, he was all right, but that's it. We've got the offset for crossings, for zebra crossings. Interestingly, I've just done one where it was the other way around. I mean, what you're saying is normally as you cross the median, you stagger the crossings so that you're always looking to your left in New Zealand and Australia, so that you can see the vehicles that are coming when you come to the second crossing. So you have a left stagger. We did one the other day with a right stagger, and everybody went, "Oh, you can't possibly have that. You can't do it." The reason we did it was because otherwise the pedestrian path would get so long that people would duck across the road at a more convenient location rather than doing the correct offset, which was taking them out of their way. So yes, we were aware of it. Yes, it's probably not the best, but it is a signalised crossing, and we felt it was safer to actually have people crossing on the crossing rather than ducking around it, because we had the correct offset. We've talked about swept paths. We've talked about landscaping or the making sure that the sight distances are not blocked by fences and planting and things like that, or even with parked cars. One that's often not considered is enough space for pedestrians. This is particularly when you're looking at splitter islands at intersections. I think the New Zealand says that the minimum width is 1.2 meters. You cannot actually have a lady pushing a pushchair or a man pushing a pushchair, as I do now with my granddaughter, and actually fit a person in a pushchair in a 1.2 meter island. It needs to be 1.8 at least. Otherwise, I've got my granddaughter in the traffic or my backside in the traffic. It's usually my backside, I have to say, but thinking about that space for the pedestrians, and as I've said, with not on the pedestrian desire line, it may be the right thing, but if it's not on the desire line, they're not going to use it, and then you've got problems. Dynamic visual obstruction is particularly important when you're looking at left turns and left turn slips. So that's where you've got a vehicle using the slip lane. It's blocking the through vehicle behind it. It's quite a serious problem with left turn slips, and there's been some very good research done on that. One set by Cherie Mason, who did her master's thesis on it, and the other is a model that was built on looking at the offsets of the geometrics by Dr. Shane Turner from Abley. If you're looking at left turn slip lanes, I would certainly look at Shane's work, because in a number of places we've taken left turn slip lanes out because of the crash problem of dynamic visual obstruction with one vehicle blocking the through vehicle. In rural roads or in mid blocks, I think the big ones are roadside hazards. Roadside hazards and the management of roadside hazards is one of the key factors that impacting road safety. Comes out really, really strongly when you're looking at your safe system assessment frameworks, because it's one of the key things for runoff road crashes, which are the most frequent crashes on the New Zealand road system in terms of their. We do tend to kill more in head-on crashes, because typically your head-on crashes is at least two vehicles, and you tend to kill more occupants, whereas roadside hazards are a more common crash. But I think from memory, we kill or seriously injure about 1.17 persons per runoff road crash into roadside hazards, whereas for head-ons, it's about 1.21, so it's more people killed or seriously injured in the head-ons. But roadside hazards are a big thing, and they're a big thing not only in terms of the safe system assessment framework, but things like the infrastructure risk rating and the Kiwi RAP or the IRAP assessment tools, which are looking to more quantify crashes and the crash reductions. It's an interesting one. We talked before about what was the difference between the crash outcomes for a safe system assessment score of 327 compared to 156, and what a nonsense question that is to ask. Where you can do work in that space is with infrastructure risk rating, where there is quite a strong correlation to actual crash performance. And again, you can look at the roadside hazard management inside that framework and actually have a look at the impact on DSIs. Other ones that we come up with are short turn lanes that don't accommodate the traffic that's going to use them. Sign reflectivity issues. Barriers and roadside hazard management go hand in hand. Drop-offs, again, they are a roadside hazard. One that's very difficult to come across, but well worth looking at, is skid resistance. One of the problems with skid resistance is skid resistance degrades by truck tires in particular slipping across the surface. They do that more on tight curves, so they tend to polish more than straights. And unfortunately, it's at the tight curves where you want the skid resistance the most. So the place where you want it the most is probably the place where it's going to degrade the fastest. Similarly, pavement defects, particularly for motorcycles, mid-curve, is really, really problematic for motorcyclists. Pavement defects are the big thing. We present historically, Julian Chisnell and I, to the Ulysses Motorcycle Convention, and it's really interesting. When we first went the first few times, the big thing was wire rope barriers, but we've talked to them enough and they know now that the good oil, the truth on them, what the research says, their big thing is pavement defects, and pavement defects that you can't see, and pavement defects that are mid-curve. That's what really gets them more than anything else these days. Merging, short mergers and blind mergers can be serious problems, particularly when you're looking at the operating speed, not the speed limits and things, and stopping sight distance, as I've talked no end about. Drainage is an interesting one, and drainage, particularly drainage paths and the depth of surface water, and the impact that things like open graded porous asphalt have on road surface water and spray, which are really important. You're better off with minimising that road surface water depth. And a lot of people say to me, you know, oh, it's on a steep grade, therefore drainage shouldn't be a problem. The steep grade simply means that the water flows further and further and further down the road before it veers off to the shoulder. So you can get very deep flow paths on steep grades. So you can have drainage problems in the grade as you go. The last one is checklist. I should change the slide. It should be prompt lists. I love prompt lists. And the reason I love them is that they save you time and stop you making balls ups. When I first started doing audits, I used them extensively. I don't use them so much now because I can go to the main prompt that we've got here. Is, you know, pedestrians that go over here. There's a bunch of questions. Now that I'm more experienced, I can look at pedestrians and go through in my mind all of these questions, but it pays when you're first starting out. And the other thing is that, you know, you might travel 2 or 3 hours to a site potentially to do an audit. There's nothing worse than getting back to the office and going, motorcycle or equestrians. Oh shit, I never looked at that. Oh crap. And then having to sort of go through without being on site, and you increase the chance of missing something and things. So I actually like doing them before I leave the site, quickly going down the main headings to make sure, yes, I have considered these. Yes, I have photos. Now, I was going to talk about photos. Photos are the key to all auditing. If you sit down, and even in design audits, taking screenshots of the design, you know, if you're trying to write that at station 1543 in the left-hand direction on the shoulder there is, or you can simply say, as shown in figure 2, photo 2, there is. You know, one of them you spend half your time trying to write a narrative about what's going on before you get to the point, which is the really important thing. And the other, you've got a picture there and you can say, you know, as shown in this, there are numerous locations where, or at this location as shown in this figure. So I find that I tend not to take too many notes when I'm on site doing the audit, but I have lots of photos. And, you know, there's always a reason why I took the photo. Sometimes if you leave it a week and you're still trying to write up and you look at the photos and you go, oh crap, why did I take that photo? You know damn well there was a point to the photo, otherwise you wouldn't have taken it. And so it's up to you to interrogate those photos, but it makes it so much easier to write up what you're doing when you're doing lots and lots of photos, or screen snips and things, and annotating those if you're at the design audit stage. Probably the hardest, as I've said, is the preliminary design, which is where the Safe System Assessment Framework is going to be more use. And you don't have as much in terms of screenshots and things to talk about, but get as many photos and screenshots as you can into your report. It makes it easier for you to write, and it makes it a damn sight easier for the audience to understand what's going on. And that, I think, is the end of my time.
We've done well, Ferg.
So I can. Oh, I'm just about right on time.
Yeah. No, you've done beautifully, and we will give people a stretch break in just a second. I just want to thank you for your time, Ferg, and for sharing that with us. And as mentioned earlier, Ferg's contact details are in the PDFs. But of course, you could just contact us, and we'll put you on to Ferg if you like. But it's always a pleasure. The only thing that would be better, Ferg, is if we did this in person together. But that will be for a future time.
That would be good, and we can always do a beer with Ferg. So I'm although I'm always open to a beer.
A beer with Ferg is our dream. The podcast or the like. We'll get it going. Thanks, Ferg, and everybody. Let's take a 3-minute break, just a quick stretch, and we'll get back into it. And I will take you a bit more through prompt lists and the like, and give you your assignment. Thanks, Ferg.
See you, Ken. Thanks, everybody. We'll see you. Bye.
Okay, well, I'm going to get back into it, and just a few little things about prompt lists that I wanted to cover to supplement what Ferg mentioned at the end there. And I'll point you in the learning management system to where we have those prompt lists, previously called checklists, and Ferg was referring to them occasionally as checklists. The reason that there was the change from calling them a checklist to calling them prompt lists is because that we never want anybody to think that just following through those questions will give you everything that you might identify as a safe system auditor. We really want people to think holistically about the scheme. And I think I've got some words to repeat that and reinforce that coming up. Now, don't worry about Wally's, because we've taken the Wally quiz out of today's session because Ferg seemed to use a version that didn't have his Wally's. So you're off the hook today. The prompt list in the Austra's Guide to Road Safety Part 6, which I'll show you in the learning management system, has some general front-loading questions, they call them. Front-loading just meaning, questions you'd ask yourself upfront about, the general aspects of the project. Why, what's the reason for the project? Are we, we're thinking about safe system energy management and those sorts of generic questions. But then it goes into these 5 prompt lists, covering local alignment, general aspects, intersections, walking and cycling, signs, line marking, lighting, and the like. And you can see that each of these prompt lists, it has columns: feasibility, preliminary, detailed, pre-opening there, and existing roads, or post-opening, which is more relevant for New Zealand, because you don't really do existing roads as such. I mean, it's sort of the similar processes are undertaken, but they're more called crash reduction studies or the like. But post-opening audits really is what we'd be thinking about. So you get these questions; they're there to spark your thinking in different areas, and it's a very good way to make sure you're not sort of missing whole areas to think about. You don't hand your prompt lists in, I should say, as part of a safe system audit. They are just there for your thinking. So you don't hand them in as part of the safe system audit process. So I just want to talk briefly again about primary and supporting treatments. I think people are generally getting their head around it, but this document is quite helpful if you're really still struggling there. It is the Safe System Assessment Framework. It lists a whole lot of things and categorizes them into primary and supporting. So I'm going to show you that in the learning management system as well when I live jump in there. Just because I think there's still a few people just struggling a little bit with that concept of categorizing treatments into primary or supporting. Next session, we've got Sam Paisley, the Safe System Solutions New Zealand lead. Some of you probably know Sam. He's been around a while in road safety. So he's going to come in and we're going to sort of talk through the general process of safe system auditing within New Zealand and some of those specifics around Waka Kotahi's requirements, what local governments are doing, and the like. So yeah, if you've got any questions around that New Zealand policy process and the like, let's ask those to Sam in our final session we have together on Friday. Now, I'm about to introduce you to your assignment, and your assignment is going to be to do a safe system audit. Now, we've streamlined it down to only requiring you to give us 3 findings, but you're still going to need to fill out a full safe system assessment matrix. So this is sort of the template you see on the screen here, and then take 3 specific findings, and you will be writing those up. I'm going to show you that. We've got a template for you, but there's a bit to cover here as to how you go through this process. So I will jump into it shortly. But the one thing before I do that is we are going to ask you to go to a site. Now, this is a site that we have prepared for you near your home or your office or whatever address you gave us. So you will have to go out to this site. It's not going to be, it shouldn't be far from where you are. Now, if you did have to travel for an hour or something to get there, just tell us. We can provide you another site that's closer to where you are. But when you get out there, we've risk assessed these sites to ensure that you can visit the site and be safe, because we don't want you putting yourself in any risk to have a look at this site. But each of them, there are areas you can park safely if you drive there, and there's areas you can stand and look at the road and the road environment without being near live traffic or anything like that. We want you wearing a high visibility vest. You are sort of out there in a training capacity, so we want you wearing a high vis vest. We don't need you to measure lane widths or anything like that, so you can stay off the road or cross at the crossing points. Don't be a hazard yourself for some reason, and that can include where you park, that you're not blocking cyclists or the like. And I'll take you shortly through a safe work method statement, which is just a little bit of something to ensure that you understand your obligations when you go out and look at this site, and that you'll agree to that. And it's very simple stuff, like that you're not going to be intoxicated when you're out there, and that you'll act appropriately and safely. Looks like Sam's messaging me possibly about his session on Friday. Okay. So I think this is where I'm going to jump. Yeah, I'm going to jump over into the learning management system.
Just a quick question here from Josh. When completing the audit, is it necessary that every team member completes a site visit, or can one member complete the site visit for the team? I believe it's one each.
So I think there's two things there. I think there's a question around the assignment, and then there's a question around general practice in safe system auditing, as how many you would need. So for the assignment, yes, every individual within this course needs to go to the site themselves. Okay. For safe system audits in general, there are situations, especially for lower risk projects, less complicated projects and things like that, where it may be that one person visits the site and the other team member is doing desktop reviews and the like. We prefer it if the whole team goes to the site as a safe system audit team, but there is some possibility around that. But yeah, good practice is for everybody to go out there and discuss things out on site. Okay, but thank you, Loretta. Jump in with any other questions that do pop up, and I encourage everybody to be asking questions as we go. But I'm going to jump into the learning management system, where you all feel very comfortable, no doubt, because you're spending a good bit of time in there. So let's start with some of the resources that I've mentioned. So if we go into the resources tab here, reference documents and resources, in here, the first one you see there is that safe system assessment framework document. it is going to provide you then with those. So it's about page 14, I think it is. If we zip down to about page 14, is where we start to get, yeah, here it is. Oh, it's page 15. Oh, it's one off. You start to see here that we've got primary treatments, and then we've got supporting treatments. There's actually sort of a subcategory of supporting treatments, but, you know, so the green are your primary treatments, and these are for runoff road crashes, and your orange and yellow there are supporting treatments. Okay, so then you've got that for head-on crashes, primary, supporting, intersection, other, pedestrians, cyclists, and motorcyclists. So you can see that helps you a little bit along the way. It's not going to, you know, there's lots of treatments that are not mentioned at all in there, and you would have to make the call from first principles as to whether it's primary or supporting. But that can help you a little bit if you're struggling in that aspect. The Austroads Guide to Road Safety Part 6 is the third document down here. And that document is this one. That's about like the road safety audit guide from Austroads. The reason you might want that is to go to the prompt lists, which are sort of right down the back in an appendix. Where are we getting to prompt lists? Examples. Lots of my audits in there as examples, actually. But here we go. We get to prompt lists in the appendix, H2, so we're down at page 122, so it's a pretty extensive document here. You see the prompt list, front loading, and then you're into H3 being the prompt list for local alignments, and you can see all these prompt questions for you, and then general aspects, H4, and the list goes on. So that might be a spot if you're needing some inspiration on looking for issues at a site in a design, that you might find some stuff in there. Okay, so we're going to go back here, and we've, you know, you catch up on any quizzes you need to, but we're down here in module 5. And what we have in here is the quiz is gone. So see, they're hidden from students. So you won't see that. And that's because it was the quiz was just how many Wallies, and we've taken that out because it didn't work. But down here, you'll see module 5 assignment. So you're going to have to go in there, and that's where you'll find information about your assignment. The first thing is to do this safe work method statement. So that's the statement of what we're expecting of you. As we say, normal stuff. There's some stuff in there about COVID. There's some stuff in there about, you know, driving to a site, and just we want to ensure that you do everything as safely as you can, and that we've tried to make that as safe as possible for you. So within that, you have a look at that, and then you go to this one question quiz, which says that you are going to act safely. You've looked at that safe working method statement. You're going to wear your high-vis vest. You'll take care. And so, you know, you're going to click agree with that as long as you agree with it all, and go out there on site. So then let's go back to this module. So when you click on that, what comes up here is a whole series of documents. You've got a Word document, which is the template. That's where you're going to do all of your work. You've got a Excel graph generator just to make your life a little bit easier. But then you see all these PDFs here. Well, they are sites, and you'll see your name. So you'll see your name next to one of these. And so we can pick anyone. We'll pick Jesse's there just because saw the name. And you can see here that you've got the 2 road names, and hopefully that'll be near Jesse's house. You've got a proposal, a design to signalize this intersection, it looks like. You've got some information about traffic volumes. Now, it's been provided for the training exercise. You might know there's different volumes, but we want you to use this because we're able to then, I'm not sure what I just did there. I've somehow annotated the PDF. Okay. What's that? Yeah, use that, and you might have to make an assumption on some. So use that when you're doing your safe system audit. Okay, so then you're gonna find your site. You'll notice some of them have a few people, and that's because probably these people all live in generally the same area. You might all know each other. Now you can go out there together if you want and chat about it, but you're going to need to submit your own safe system audit, and we don't want to see the same text in these. So be aware of that, because we are issuing you with an individual safe system audit certificate. So there you go. There's another one, a bit more interesting one. Not sure exactly what's going on there, but these should all be fairly close to your house or your workplace. Okay. If for some reason you say that's nowhere near me, that's on the wrong island, don't worry, we can issue you another one. Just get in contact at the training at Safe System Solutions. So then you've got the Word document template. Okay, so you've got the Word document template there, and what comes up, this is the actual Waka Kotahi template, and you're going to need to fill it out. So you could name your project name, location, just, whatever, just anything there. We've put it here as a training course 1. And then you're going to go through and fill out the bits. Now, I've highlighted bits to make it easy for you, because this is standard text that will always appear in all of them. That's Waka Kotahi written text. It's just there. But you can see here, actually, these should be highlighted as well, sorry. You're just going to fill out the bits, a bit about, what type of audit was it? Well, the team's just going to be you for this one, for the training exercise, when you went out on site. Bit of description about the existing conditions and context. Now, this can be brief in terms of comments around the function of the road, speed environment, things like that. In a full safe system audit that you're doing, you'd probably dig a little bit further, get a lot more information. You're really going to be strapped for information in this mock exercise. So a few dot points there. Explain a little bit about what's going to be done. You could put a snip of the drawing in there if you want. That's a very handy thing to do. And then you're sort of into the safe system or assessment process of the safe system audit. So you're going to actually not start with the scores and the numbers. You're going to start with the matrix, and you're going to fill out lots of dot points around each point here and here and here and here, and all these down, fill out the numbers. Then you're going to copy that whole thing after you've completed it. You're then going to create a excuse me. You're going to create a copy of it. So you've got a second one there, and you're going to then manipulate it as you would. So you're going to cross things out. You're going to change information. So as I've shown you in the previous module, I've got an example of all of this for you if you're thinking, oh, I'm not quite sure what he's talking about. So you'll fill all of that out as per looking at the design and the site. And then you'll go in and you'll take 3 safety concerns, only 3. And you will write out your safety concern, issue, risk rating, recommendations, safe system category. You'll risk rate them here, likely, minor, resulting risk rating, moderate. You'll have to use the risk matrix back up here to do that, to work out what it is, what the resulting risk is. And you'll fill out information, you'll put a snip in. So, you'll be writing lots of stuff here, blah, blah, blah. And your, recommendation and, supporting, and put some snips in. And then you'll be able to delete this, and that'll be a nice audit finding with a snip and like that. You leave all of this blank because that's not for you to fill out. That's for whoever you hand it to. So you'll do 1, 2, 3 of these, and that's it. Then the only last thing, write a bit of a conclusion. Well, you'll write a bit of a conclusion, and then you'll put a photo of you at the site to prove to us you actually went to the site. Safe System Auditor in training, you pop your signature, and that's it. The one thing I suppose you won't have done yet is after you've done your matrix, you've got your scoring, you then will add the scores in here. You only have one design option, so you'll be able to delete that row. And to make your life easier, back in the learning management system, this graph generator is just a little thing to make those graphs. So you'll be able to put the scores you have in there, whatever your scores are, and you'll have to put your own scores in. I'm just popping some in to get us going. You'll see that they appear there, and we can then you'll add scores there, and it'll produce a graph. You can maybe take a nice snip of that if you want. Go back in here, delete that, pop yours in. Hey presto, easily done. So you're going to finish all of that off, and you're going to then go back to the learning management system. You're going to hit upload, which is not there because I'm in the teacher mode. And you're going to drop your PDF in there. Due date is Friday the 15th. So you've got a little bit of time on this one. I suggest you get onto it fairly quickly. You can ask questions in the next session if you've got any, or of course you can come and organize a one-on-one session with us at any point. But I want to show you here in Module 5, we have an example Safe System Audit Report. Okay, we've created this to try to help you along so you can see what we're expecting. This has been created for training purposes. It is an existing intersection there in the Auckland area. But you can see here, you've got a bit of an exec summary, but you've got that information about the process. You've got the risk thing, which is all in there. Then you can see here a bit of information about the audit type, the audit team members, and you'd write your name there. Some overarching bits about the meetings and site inspections, some information about the project, a little snip of the existing additions, a snip of the design there, the drawing number, which you don't really have. Then you can see there's the graph, and there's the commentary around the graph, a little bit of information there. And then you can see for each safety concern, we've got heading, likely, minor, moderate risk, description of it, snip from the design or a photo, recommendations, supporting treatment. So we want to see that 3 of those sorts of things represented, and hopefully these will help you a little bit along the way. bit of a conclusion, signed, and photos. Yeah, as we say, we would want to see a photo of you on the side. But here's a bit of the matrix. The order of this one's slightly different to what it is, but that's fine. You can see there, you'll be putting dot points about things you've identified, similar to what you did for assignment 2, but these are a bit more detailed. So that's the existing conditions. And this one is the design, where you can see there's crossing out, there's new stuff added in red. So we'll be expecting 2 matrices and the 2 matrices for this. Now for photos in a real one, you'd be, certainly putting site photos, but we're happy for you to just put that one photo of you on site. We don't need to see all the site photos from your assignment. So hopefully that'll help you a little bit. It's kind of more what you would genuinely be producing if you're doing a safe system audit, but it's got the elements for your assignment that you'll be able to follow. But just go to your template, fill out the information you need, and find your site there. So I've covered a lot there. You might want to go back and watch the recording when it comes up to just catch anything I missed. Loretta, any questions come up that I need to cover?
Oh, just to quickly confirm on that Word template, it's just the highlighted sections that the participants need to fill out, not the strike through. Is that correct?
Yes, just the highlighted sections, although I missed highlighting it here.
I've just updated it, so everyone will get the updated one.
Okay, thank you so much. So and that's a good point. Download it from when we finish today, because if you downloaded it yesterday for some reason, we managed to do that, it's not up to date. So download the latest one. So just the highlighted stuff. If stuff's crossed out, don't worry about it. We've said, for this purpose, we're not going to do it. Like you genuinely don't have prompts around the reason for, like, you won't know the reasoning behind the project and some of this stuff, because, we're not giving you all of this background. You don't have growth models and freight movement information. So we've said, well, we won't worry about that for this. We're just about you filling out the matrices, identifying 3 issues and reporting them really well. Okay. Any other questions? Well, next session on Friday, we're going to do a little bit of practice safe system auditing, get you in the groove of it. We'll do that as a group. So you'll get a bit of practice on this. But of course, anytime, if you're getting into this and you feel overwhelmed or you don't know what you're doing, get in contact. We're here. We're here to help you.
One last question from Josh. Can you use the RSA findings from previously completed audit on RSA course?
So it's obviously Josh has somehow got the same site because he's probably in the same area, and that's in our bank of sites. I'll let you do that. You can use the same one, but you're going to have to go through this, safe system audit process now for the whole site as well. Okay. Any other questions or comments?
I think that's it.
Okay. Well, you've been given a lot of information and tasks to do. It's all in the learning management system. Just download it, follow it through. And don't leave this to the last minute either. Let's get on to it. Thanks,
Ken. Bye, everyone.
Bye.